Sweet. This isn't fun anymore. That's painful. I think that's enough adventuring for today. I haven't ridden a bike in over 20 years, let alone an e-bike. So when I was offered one to try out, I was intrigued to see how well this tech performs. Well, let me take you on a ride. So here's the thing, and my honest answer, it kind of sucks. But don't get me wrong, I'm not actually talking about the bike itself. The bike is awesome. As you can see, it's taken me up this hill and I'm not even pedaling. No, what actually sucks are British laws. I'll stop here just so you can hear me. No, an e-bike's limited by law to 15.5 miles an hour. And if I'm honest, I can understand that. That's an absolutely sensible law because over that speed, these kind of things get dangerous. No, it's not that. It's the other laws surrounding it. So the motor is limited to 250 watts. And that limitation is across the board, no matter what e-bike you get. So there's no point spending huge amounts of money, it seems. Fortunately though, with the Cyrusher Ranger, the motor actually can produce 750 watts. And technically it's unlawful, but you can unlock its power. But here's the thing, you want to unlock its power if you're a little bit heavier and you want to get up a hill. And personally, being a non-cyclist, I don't want to have to wear Lycra to get the best potential out of my bike. So I've actually come up with an idea that gets me around the law and enables this bike to be actually quite useful. First of all, let me show you what else I've made illegal on this bike. So I added a twist grip, which is completely illegal. Also thumb accelerators, highly illegal. However, that's going to become very useful shortly. And the assisted speed limit goes up to 30 miles an hour now. What I did is I added an unsuspicious button just down here. So if you have a quick peek inside, that button is linked to these two wires here. If I disconnect that, these two wires, when connected, is the limiter. That's now restricted to 15.5 miles an hour. So just to be clear, I intend to use this legally on the road. Hence why I've added a button, so I can switch between illegal to legal. And I'll be doing the same for my twist grip and thumb drive. This will be disconnected and the key removed, and the twist grip will just have its cable pulled. Another irritation with the law is I can't ride this on public footpaths. So for legal use, I'm restricted to roads and bridleways only. That is, unless I have permission to ride this on private land. So you might be thinking, if the rules suck so much, what are the benefits of having an e-bike? Well, let's just say, hypothetically, you arrived in the UK on a small rubber dinghy, just to find you'd accidentally dropped all your credentials into the ocean. Well, an e-bike is certainly better than a regular bicycle, and you don't need a license for it. But let's say you could get a license, surely having a regular motorbike is better. But one of the best aspects for going electric is it's almost free to run. That's if you've got one of those fancy solar charge inverters, or we can charge it at night and get a nighttime tariff. In the meantime, I want to make this bike actually useful, so let's do some R&D. So I came up with a really simple flatbed trailer design. Underneath we've got hidden compartments for all the electronics, but to do something a bit more interesting, I've also created a camping module. This will be welded out of aluminium, and I'll use the laser welder for that. And I am not sponsored in any way, shape or form for saying this, but if you're looking for high quality CAD modelling design services, I recommend Convert Designs. So I've actually known these guys for years and they're very good friends of mine. Basically, if you've got an idea that you want realised into a final product, these guys will help you with it. They are experts in design and the software that they have is way more powerful than mine. So if you do have an idea that needs realising, I recommend these guys highly. Just say Joshua Delisle sent you their way and they'll look after you. And for the electronic side, we have a 2000 watt motor. This came courtesy of Viva with the electronics controller, and everything's getting powered via this power module. This is a Vertiv R48 3000D3. It turns domestic 220 volts into 48 volts at 3000 watts. And if my calculations are correct, this will reach about 30 miles an hour. And that's by using these drift trike wheels. You can see I've got a chain sprocket this side and a disc brake this side. This has 58 teeth, the motor has 11 teeth. That gives a 5.27 to 1 ratio. There'll be links in the description for all these things, but this was about 100 quid for all those components. The wheels though were a bit more, they were £42. So I've gone ahead and cut all the steel. But one issue I have is that it's all gone rusty. Let's clean it up using lasers. And to do this, I'm using the Photonics X1 Pro from X Laser Labs. I've currently got it set to 80% power, 200 Hz. Done. By the way, if you're interested in getting hold of one of these lasers, the Kickstarter campaign obviously is ended. They were going for about £2,500 and now they've gone up to £4,000. There are scams out there to say you can get one for 40 quid. They are a lie. Do not fall for it. You may or may not receive a soldering iron if you do. But if that sounds like too much money, I'm offering you a brand new one for just a £5. That's of course via the raffle competition. I've actually given one of these away previously. I shipped it all the way to the USA for John Manning. And basically every time I do a video and I receive these products for testing, and chances are I'll put it up for a competition on raffle. So there have been lots of previous winners. Raffle of course is hosted in the UK and under strict regulations. And if you join the competition and you don't win, have peace of mind that you've helped me make this video happen. And I've tried to cram pack this one with as much useful information as possible. And it's all because of your contribution. Let's get into it. Right, so let's crack on with some welding. You can see like a good boy, I've sanded up the ends. That's because even though we've hit this with a laser cleaner, all we've done really is turn the rust oxide into a different oxide. It's now more like mil scale. And just like TIG welding, laser welding still needs it to be squeaky clean, so I've just brushed along it with a grinding disc. So I've done a few more things, and now it's ready for tack welding. So to keep tension on these spacer bars, I've also added ratchet straps. So those keep the whole assembly squeezed together. Then, after checking corner to corner, so that now says 2208, and now that side says 2208. It's now perfect. And making sure I have line of sight, I also check to see if the frame is twisted, just by looking along it. And what I mean by that is I'm looking across this edge here with the opposite edge on that frame. So by lifting our eye up and down, we can see the horizon line. So if you begin to see the frame higher than one side, you know there's a bit of a twist. I would say it's not too bad. Right, so we're all tacked together, now we can begin welding. Just beautiful. And we're still bang on square. So now I'll flip the frame and repeat the procedure. And what was good to feel is that this is a very lightweight frame. Right, so that's all the face is now done. I'll flip him up. And what I'll do is I'll just grind off all the little tacks that I've made. So if you're thinking, Josh, you made that look way too easy, it must be harder than it looks. Nope, laser welding is that easy. So I'm getting beautiful, consistent results every single time All I've got to make sure is that my angles are correct. And for those who have doubts about the strength of the welds, I did a whole test video comparing it to MIG, TIG and stick. So this low powered unit, which only does like a 2mm weld, is obviously no good for big industrial applications. But for things with just a wall thickness of just a couple of millimeters, it's absolutely ideal. So this is a test piece that I did for this project. It's hard to see, but if I show you the inside of this weld just there, and get some light in there for you, you can see I've got 100% penetration. Even these welds here, if we have a look inside, don't know if you can see in there, but that is ideal. You could also say I've gotten into the groove. Right. Now you might be wondering, why isn't this bar dead centered? I'm asking myself that same question. So those that have been watching a while know that I love rivet nuts. And this is the perfect application for them. Right, so I've got some parts to cut out of 6mm thick plate for the tow hitch. And my tool of choice, I'm going to use the arc Droid, courtesy of Extreme Plasma UK. And Rob also delivers to EU if you're interested. And instead of the laser, I'm going to use my P51D from Artec. This plasma is much faster at cutting than the laser and can cut up to 20mm thick. You can see I'm using flat bar stock rather than sheet steel. Now for me that's a lot more cost effective to store and buy. And to really save on material, I just want to highlight a new feature that I have. And that is the Arc Droid Corner Wizard. And what that does is allows you to align your plasma torch exactly on the very corner of your material. That slots into the hole there, put a bit of pressure on. Now I can zero this on the Arc Droid controller. That's it, I can remove that now. And now instead of cutting a whole part out, I can actually use some of this pre-cut edge. So that was obviously a lot quicker than just cutting the part out without utilising that corner. Right, so the tow hitch can now get mounted here. In case you're wondering, I put the spacers in here because the riv nuts have like a little bit of a flange. So if I didn't account for that, these holes wouldn't line up. Alright, let's fit this on then. So the reason I've made this a bolt-on attachment is so I can change the hitches. I've made this hitch specific to my bike. So if I want to use it as a regular trailer or for a different bike, I'll need to change this. And to mount the brake caliper, I've just welded a bar onto the chassis. Very simple, not complicated. So now I've gotten to this stage, I've decided to make a design change. So to go on top of this, I've got some aluminium tread plates, similar to this. But as you can see, these spaces are quite wide, and if I just simply chuck a log onto this or something heavy, it's just going to collapse. But my original idea was actually to put a sheet of marine ply on top of this, nice and thick to add strength, and then this alley plate on top. But I thought about it a lot, and that's a lot of added weight and a lot of added cost. So instead, I'm just going to increase the amount of bars. As you can see, I've pre-cut some here. So So these will distribute the weight across the aluminium a bit better. But more importantly, it's now saved me a load of money and a load of weight. Because let's face it, marine ply is not cheap. So this stuff's 20 quid for 6 meters. Laser welding, FYI, doesn't matter if you're welding horizontally, going vertically uphill, or vertically downhill. You'll get the same level of penetration all the same. So now I want to install anchor loops for ratchet straps. And to make those, I've reinstated my miracle bender. So for the anchor points, I'm using 10mm square bar. This is mainly because it's just what I've got lying around, but it's also slightly thicker than the eye hook, which I'm hoping means that these would give way before this does. I'm using a square on getting a measurement. That'll give me the direct center. And I'm going to tighten this back plate against the material and bend. Simple as that. They should be very strong anchor points. Right, so I'm fast running out of workshop space, but I'm now ready to make the fenders for the wheels. And for that, I've decided to go for stainless steel. And just to double check I'm making the best use of my material, I've got another little gadget to show you. This is a laser pointer stylus. So I've had to zoom in so you can see it, but you can see there, little laser pointer. As I move the stylus around, you can see I can very accurately plot the position of this thing. This is also really handy to do line tracing around objects, which has got to be one of the best features of the Arc Droid. I've already got a design in mind though, I just want to make sure my parts fit on this piece accurately. And looking good so far. Yep, that will do nicely. I think I'll install the plasma torch. No collisions, good. So I just want to emphasize I'm going to be using my PAPR system. That's a powered air purifying respirator. That's because on stainless steel especially, you're going to get hexavalent chromium oxides, which are terrible for you. So make sure if you're doing the same, protect your lungs. Well, so much for obstacle avoidance. That was entirely my fault, I didn't check it properly. But anyway, I've chosen to use this 304 stainless steel because it's left over from a previous project. It could easily be made from more of an aluminium or even mild steel and get it powder coated with the rest of it. But because I have this stuff, this will actually be even stronger and will last a lot longer as well. So simply put, I'm going to mould this flat piece to this curved piece. Now I could put this through my rollers first, but not everyone has access to rollers, so I thought I'll try without. So instead I'll just simply start tack welding it on and gradually pull the pieces together as I assemble it. So before I weld this, I might as well mention what a lot of people with 60 years plus welding experience will be going on about in the comments section. And that is, for stainless steel work, you really need a high level of cleanliness. So this is already getting contaminated just because it's rubbing against steel. And therefore, those steel particulates are getting embedded into the surface, which will eventually rust. And the other thing that I have demonstrated in previous episodes is protecting the back of the weld. So putting a gas shield by kind of taping off all of this area, putting a pipe with an inert gas, for instance nitrogen or argon, but in my case I'm not going to do that. I'm just going to do it the simple way and just weld it. So yes, it will leave oxidization on the inside and potentially something called sugaring, which is common with TIG welding, but because this is laser welding, it's so minimal I'm not going to worry about it. And we're going to remember that this is a mud guard, it's not pharmaceutical or for the food industry. I am simply just going to speed weld this using lasers. And this, by the way, is how it looks after a polycarbide brush. That's something like this. And this is the inside. As you can see, very minimal oxidation. and plenty of penetration. So we've got just a few things left to make. I first of all got to cut out this tow hitch attachment for the bike itself, and I designed it completely within the Droid tablet. So I've got 150mm by 6mm flat bar. We'll just press play on that. Right, so that was quick and painless. Right, so it appears I may have miscalculated where the holes should be. To fix it, I've got another little tool to show you. This is a center hole finder for the Droid. Got a little divot on the inside there. You can see that's for aligning on a center punch hole. And this cone is meant to engage with the torch. However, it's just the right size that if I put that on the hole, I can now align the center of the hole to the torch. So if I zero that on the controller now, take that away. And so on the Droid controller, I've just designed a little slot to cut out, so we'll do that now. And so that has fixed it. All I've got to do is clean up these sharp edges for powder coat. So the last thing to do other than cable management is to fit a handbrake. And what I've done is I've coupled a toggle clamp with the master cylinder. And to fit this, I'll just simply weld on this bracket here. Alright, so we'll attach the master cylinder. So you can fit these in this position or in the vertical position. You just have to make sure that the oil reservoir here, with the oil level indicator being at the top, that's where your air bubbles will collect. So looking down on the assembly, you can see that when I pull this lever, we've got quite the range of motion. The brake cylinder, however, just needs to have a little movement. So what I found the optimum position is when the handle here is aligned with the angle of this back pivot. I'll lock that off now with a clamp. So now that should be the brake off, and then when I lock position, it should be brake on. And I've just tried turning the wheels, and that has definitely got the brake on. So now I know exactly where to mark those holes. Brilliant. So you might just be thinking, the way I tidied these ratchet straps looks a little bit messy. Well, actually this is done on purpose, because when people come to undo these, let's say on the off chance, what they tend to do is try and unpick every single one of these knots. The truth is, you don't actually have to. You can just pull it. So everyone's got an opinion on how they tie up their ratchet straps. But for me, this is quick to deploy, quick to undo, and not a lot of people know about it, so it confuses them when they see it. Done. So that's all gone to the powder coaters now. Whilst we're waiting, I might as well start on the camper. So to get these perfect curves and angles, I've had to develop some templates. So I've flattened the profile, and then these individual cutouts I've separated as a flat image. So I've saved those images as a PDF to scale, and then I use the free software Adobe PDF Reader, because when we come to printing, we can use something called poster mode. And so as the name suggests, we can then print off our big templates just on regular A4 or A3 paper. And so now I simply use a bit of tape and some scissors to splice all these together, and then cut them out as a singular pattern. Now I'm going to show you a little trick on how I splice these together. You can see there is a bit of a margin, and I need to align these lines with these ones. So using one of the templates, I cut little V's just where the ends of the lines are. So you can see here I've cut across exactly to the end of that line, and then snip that little triangle out. And so now I can align this with those other two lines. Like that. So Adobe has options to put on alignment marks also, which does make it easier. But anyway, once you're taped together, obviously the next stage is to just cut it out. Alright, so I've finished cutting out these templates. Now I need to splice some aluminium together. So this is where it's going to get particularly challenging. So I have here two full-size sheets of aluminium. And these are 2.5 meters by 1.25 meters, which means when they're together, that's a 2.5 meter square, which I can't fit in my workshop, and I've actually maxed out my garden as well. To prepare the edge for welding, I've got one of these deburring tools. This is going to give just the slightest chamfer for when we do the welding. So then I'm going to give it a wipe with some acetone. So when it comes to butting together sheet metal for welding, there are actually several processes many will debate you should take, and that is to leave a gap or not have a gap. I'm actually going to have no gap because the laser is able to penetrate all the way through this, no problem. But I am going to try something very unconventional, and that is I'm not going to tack weld it at all. The process I'm going to use instead is use these high-strength magnets covered in Teflon tape. Teflon being the material with the least amount of friction, so I can slide these up and down the weld. And obviously because there's a clamping force, it should hold the sheet metal together as I'm welding it. And the reason simply is because the welds that I tested this on came out rather perfect. So let's see if I can do the same precision on a 2.5 meter weld. Oh, I'm risking it so much. This is British weather. It's sunny now, but it could rain at any moment. All right, got it set to 70% power, and that's at 200 hertz with a 2mm weld bead. Got a bit of foam to stand on so I don't wreck everything. All right, let's go for it. Well, that was a great success. I cannot wait to peel back this plastic. These aluminium welds are looking sweet. Alright, so now I'm going to start applying my templates. And again, I'm going to use magnets with a little steel washer to go underneath. And then I've got one of these jumbo fat markers. I'm just going to kind of lap it over the edge. Right, and I'll flip this and do the other side. There we go. Right, and so to cut this out, I'm going to use some electronic shears. I highly recommend these for any kind of sheet metal work. So I'm going to do a quick cut first, meaning I'm not going to go right to the line, and then I'll do a final pass, just taking that last little sliver away. By doing it this way, there's minimal distortion to the metal. So interestingly, I didn't get full penetration, or did I? Almost, it's like 90%. I'll just deburr it a little bit. Right, I need to flip this now. Oh, it's a good thing it's light. So before I start welding that shell together, I need to make a little aluminium frame. Aha! It's actually acting like a parabolic mirror now. I'm getting blinded. So the weather today was atrociously hot, certainly too hot to be standing next to a parabolic mirror. And because of the extreme heat, I found myself rushing and making a lot of mistakes. So I've waited for the sun to go behind the trees there, so now I can do these vertical welds. You can see I've been tacking all the way along the edge. But I don't know if you can see that, but I've also feathered my tacks as well, meaning I've just gone over them with a grinding disc just to create that little groove. And so when I fully weld the seam, hopefully that doesn't stand out. Right, so here's some close-ups of what I've just done, and come on, you've got to admit, that isn't that bad, is it? Look at that. I tell you what, on aluminium especially, the welds are coming out great. As long as everything's prepped correctly, you should be able to achieve exactly the same as I have. So I've just got to finish doing the seam down here. To do that, I'm going to put it on its side. And then I've just got to build the door for it, insulate it, and then it's done. This is where I realise I've made a very big mistake. I forgot to trim the ends of this part off, which I needed to do. Fortunately, it's only tacked on, so I can remove it. Right, so it's gotten ridiculously hot, and it's also incredibly dangerous to be messing around with lasers outside. There's always a risk that someone might get a glare from it, so I'm going to move this whole thing inside now. So I've got some aluminium flat bar, just like this one. You can see I've already pre-formed it. That's going to go on the inside. And I'm also in the process of bending up this flat bar to create a safe edge around here. But I'll also be able to put LED lights there, which will create a really nice effect. And so many of you will know that bending flat bar on its edge, especially aluminium, is quite difficult. And so you're probably wondering my method for doing it. I'm just simply using a vise. Putting the flat bar in, I'm using my knee to tighten it up, and then trying to hold this as straight as I can. I'm just going to bend it ever so slightly. And it doesn't require much for a big radius like this. Put it through a little bit more, repeat the process. And if I overbend it, which I have done a little bit here, I can just put it in the vise and squash it a little bit. After that, it's simply a case of just aligning it up and seeing how we've done. So I've still got quite a lot of work to do. Right then, I think we're ready for more welding. So you might have just seen by the expression on my face that I found a limitation with the laser. And that is, as compact as they've made it, it's still not compact enough to get into that tight space. Couldn't quite get the right torch angle, so I'm going to have to attack it on the faces only. It means that that weld isn't as strong as it could be, but it should be alright. So that's all the welding now finished on the shell. Most of it came out really nice, but there are some really ropey bits. There you go, just to be real with you, you can see I've not got it perfect all the way around. The good thing about tiny welds though, they are quick to clean up. So this can now go back outside. I should probably get some help to do stuff like that. Right, so we're on the home stretch, and one of the final pieces is the door. And I've run out of new material, so everything I'm building it with is going to be the offcuts. I did, however, buy some hinges, a door lock, and a really cute little nautical window. But look, I gathered you've seen quite a lot of welding and fabrication now, so I'm not going to be able to show you anything new with this. So how about we just do some YouTube magic? Something like this. Whoa, there you go. So this is nearly complete now. I've got my window, my locks in place. If I just take this apart a moment and take that off and that off, this panel will eventually be riveted on. So now you can see how I've constructed the thing. These parts here for the panel to be riveted to. Got my lock mechanism here, but you also notice I've got a bead around the outside. This beading is going to create a bit of a door seal. I've added these stainless steel hinges. So this is ready for the wrap to be peeled off and assembled. But before we do, I want to fill this cavity with insulation. And what I'm going to use is potentially extremely messy. So let's take it outside. Okay, so we're outside. You can see on the door I've taped off areas and I've given it a surface finish. And that's because we're going to be using thermal acoustic spray foam. Alongside that I've got a spray foam applicator, which also requires a foam cleaner. So I paid £12 for this brand, which apparently does 3 meters square. So in theory this whole bottle should do the whole camper. But I have never used stuff like this before. This is all the first time for me. So what I do have is a test surface to try on. So it comes with some flat spray nozzles. Take those off, and I believe it's nozzle A that we want, and this should just squeeze into our applicator gun. Stick on our nozzle, which does not seem to fit on my one. I think I'll just drill that out to match, I think. Hang on. So there we go, I just drilled out the plastic just until it fitted. And for the safety conscious, we're wearing latex gloves, and I'm using my Artec welding and grinding hood. And that's so I can use my PAPR system with some nice filtered air. Alright, so I'm giving it a bit of a shake. Now we're ready to get spraying. Well, that was a good start, wasn't it? Right, so it turns out if I'm going to do this, I either need to wait for the first layer to dry or try and get it all done in a wanna. I think I'm just going to go for it. I'm hoping that it will expand a bit more. So before I move on to the main camper, I'm going to let this cure and just give it a skim over. In the meantime, I'll disassemble this, give it a clean with the foam cleaner. That was really irritating, the top came off this. This was the cheapest one I could find though. So to be fair, I've got it well contained. I do wish I used my brain a little bit more and taped off all of these outside areas. But it seems to be coming off quite easily, so what I'll do is I'll just give it a bit of a light sanding around here and it should be fine. After about 10 minutes it's formed a bit of a crust, but I can tell it's still a bit squidgy in the middle, so I'll leave it for a few hours now. But I like to learn by just having a go and getting a feel for it, and what I've learned is that you need to go a little bit slower than you thought you might have to. But I think I've got it just right, but what I should have paid more attention is how it formed on the edges. And these bulbous areas are where I've overlapped it. But we'll let this cure and I'll come back with something to top that off. Right, so it turns out with an old bow saw, a few rusty nails and a bit of ingenuity, we can create a horizontal saw. So we've had about an hour now, it feels more robust. Let's see if I can cap it. There's a few voids in here. I'm going to have to poke a little foam into them. Right, that was marginally successful. I was very surprised with these little voids. I've just kind of stuck bits of foam in them. Got a big void up here and a little void there as well. So I think all this really needs is just a little bit of an edge cleanup and I can stick that panel straight onto it. Oh, it's coming together nicely. Right. So then, as you can see, I've taped everything off. I even got a bit of old Amazon packaging to kind of stop the overspray going that way. Now this time I'm going to use a different expanding foam. This one apparently will do the exact same job, thermal and acoustic insulation. But not only that, this was less than half the price at just £4.50 a can. This is water activated, so I've got to spray the surface first. We'll get our safety gear on and have a go. That did not go to plan. It's So let's just reflect upon what was essentially a complete disaster. You can see at the back here, I used 6 of these. 6 of these. So I can tell you without a doubt these are not the same thing. Also, when it was forming the crust, a lot of gases were building up. It was just kind of like falling off. I quickly fashioned this little float. It's just bits of scrap wood with some of that Teflon tape on it. And what I was doing is basically trying to push the stuff back on. But as you can see, I've now compressed it and it's just a mess. So in the end, what was left in this bottle, I used to finish this bit here, and I can honestly say this went on way better, a lot more even, a lot more easier to control, and it seemed to go a lot further. This stuff was just awful. I can't believe I did it without testing it. What an idiot. You can see as well from this side, I tried to use it more sparingly, and so now it's got loads of like holes and gaps. It's just not ideal. So the temptation now is, do I carry on? As in, should I buy more of the good stuff, the stuff that actually worked, and kind of go over the top of this? The other alternative is to have twin skinned this and then have like a 2-part that you mix together and it kind of fills the cavity. I didn't want to do that because it needs very specific conditions. It needs all the right temperature and everything. This I thought would be the easiest solution. Turns out it isn't. The best solution, I think, would have been to use sheep's wool from a local farm, but then I still would have needed to have put that second skin on, which would have cost a lot more because aluminium sheets ain't the cheapest of stuff. Oh, this is getting expensive very quickly. Don't make my mistakes, will you? Right, so whilst I'm waiting for a new shipment of foam to arrive, they finished the powder coating of the trailer. So let's crack on assembling that then. Tell you what, I am really pleased with that. We are now finally ready to put it all together. So to cure that rattle and to stop this from being marked, I'm going to use a bit more of this Teflon tape. Much better. Right, so for those that are interested, let's take a deep dive into the electronics. I'm now going to show you exactly how I'm putting all this together. However, I need to stress the point that I'm not showing you for you to copy. I'm using 220 volts of electricity, which, as you should know, is potentially very dangerous. So what I'm actually doing is inviting constructive criticism from professional electricians. And so I would highly recommend you don't trust a thing I say, or what anyone says for that matter. Do your own research first, and if in doubt, leave it to a professional. Right, so to make this 220 volts safe, relatively, I'm going to make sure that the ground lead is earthed to the frame. So you can see here I've ground, drilled and tapped a little hole, and so my earth lead can get bolted on just there. There we go, nice and tight, nice and secure. So I guess I'll point out the reason I'm using 220 volt is because that's what my battery produces, which is the UK's common domestic outlet. Now the specific battery I'm using will detect if there's a voltage leak. Let's say my live wire had a bit of a break somewhere and it started arcing against the frame. Without the earth, if I was to touch the frame, I would then get a deadly electric shock. So instead, a signal voltage travels back through my earth wire, where my battery pack detects this voltage leak and shuts down the whole system. This is called RCD protection, otherwise known as RCCB, which stands for Residual Current Device or Residual Current Circuit Breaker. Either way, that's very important. So I'm going to interject here and mention that this is what I'm talking about when it comes to an RCD. This is one that you add to a generator or an inverter setup, All houses today should have these built into their breaker switches. Now the battery I'm using does have built-in safety features, however with further investigation it doesn't have what's called an RCD. So for part of this video I use this system without the RCD, which of course is extremely dangerous and risking it, so I want to make this absolutely clear. It's definitely better to have a direct current like 12 volts or 48 volts rather than a 220 volt system. So this can now be plugged into my DC power supply. So this power supply is basically dropping the 220 volts down to 48 volts, but it's also turning it from AC alternating current down to DC direct current. And also made sure that the capacity of this was greater than the motor itself. So basically when the motor is spinning at full whack, this isn't going to overheat too much. Now it's worth noting, yes, this has an inbuilt fan, but it's going to be in an enclosed space. That could potentially be a hazard if the temperature builds up too high. There is, however, a thermal cutout, but you'll also notice that this is pressing hard up against the aluminium plate on the bottom here. And so when the motor is at full use, we're going at top speed, which means you're getting the best cooling for this also. That's because this whole frame is going to act as a heatsink. Right, so the next cables that I have here is one to the motor and this little one to the thumb controller. Both of these go back to the motor controller, which is this. So you can see we've got a junction box here. You can see the wires are nice and colour coordinated to match. But on the live output, I've put in a fuse box. This fuse is DC rated to 40 amps. I chose this based on what was recommended for this motor controller and that motor. So the purpose of the fuse is to protect the motor. We've got a huge amount of current available from the power supply, and if the motor is straining too much, then there is a risk that the wires in the motor will suddenly get too hot and combust, leading to an unfortunate burnout and permanent damage to the motor. So what the fuse does is sacrifices itself to protect the motor before that happens. So I'll attach my corresponding motor wires to the block and then attach the cover. So now these connections are properly insulated. We've got the 3-phase wires going to the motor, we've got the negative 48 volt DC input and the positive DC input going to the fuse. We've also got some control and monitoring inputs here, that will just get clipped together. And then we've got throttle and electrical lock, which will go back to my thumb switch. Everything else appears to be unnecessary, so I've just clipped it all in this kind of bag, just to make sure it's safe and out the way. Right, this can all get mounted in now. And this junction box and fuse, I plan to have just here, like that. And to eliminate the amount of screws I'm going to use, I'm simply going to use a construction adhesive. There we go, I'll leave that to cure. The reason I used an adhesive is because with screws there's more chance of arcing. The adhesive I used is a good insulator in that sense, and it's also very, very strong, so I thought this would be the best method. So the adhesive is fully cured, so I can remove these clamps. And now to secure these units in place and stop them moving around, I laser welded a special clamp. Those are now held securely in place. They're pushed nice and tight against the aluminium floor also. The fan can still run and create airflow around everything still. And if I need to at any point, I can actually drop the panel from underneath. Otherwise, that's now finished. So you may be thinking, why aren't I using just 48 volt batteries and having those situated in these cavities around the trailer? Well, that's a really good idea, and I should do that really. However, I wanted to make better use of my solar charger units. And those, of course, produce domestic power on demand. I'll show you the specific unit I'm using in a minute, but I really want to know your thoughts on this. I am fully aware that a little knowledge can be a dangerous thing. And so I hope I've put the right precautions to make this safe. Either way, we'll see what happens. Let's get the top on. So lastly, before I put the floor on top, I'm going to go around with some more of this sealant. That's to stop any water coming round in underneath, because there will be a little bit of a gap where these fixings are. What's really good about this stuff is if I just leave a little bit hanging out the end there, that will dry, but it will also seal and protect the rest of this. Whilst on regular silicone products, if you don't properly seal that cap off, the whole thing gets wasted. But this, when I want to reuse it, just pull that end part off and carry on again. It is done. Right. Here we are, fully together. So to power this monstrosity, we've got the Anker Solix F2000. So these things aren't cheap, retailing at 1,300 quid. but it does store 2048 watt-hours of energy and can take 1000 watts of solar input. It's also an app-controlled system and has lots of safety features. But some key details is that it only takes an hour and 40 minutes to get to 80% charge from zero, and it can take peak powers of 3600 watts. And as you've seen previously, I can use this to run my welders on site, including my laser welder. And on top of that, it's a 5-year full warranty and a 10-year lifespan guaranteed. It's also a lithium iron phosphate battery, which apparently is fully recyclable and better for the environment because it doesn't use any cobalt or nickel. Right, so everything's plugged in ready. I've also got my thumb switch now engaged. Whoop. Right. Now obviously to get here, I've already gotten a little feel for it. And I'll be honest guys, it's not looking good. I'll just give you a demonstration of the issues I'm facing. Right, so got it powered, just using the trailer, alright? Turn. I'm exhausted and I'm not even pedaling. Whoa. Right, proves my point, doesn't it? Turn that off because it's about to rain. Well, this is tipping it over. Right, come on. Come on! Right, it's the first sunny day back. It's actually been a couple of weeks because it's been raining so much. So you can probably see why this video's taken so long to get out there. So now let me show you exactly what the problem is. So basically, with the hitch being up here like so, the weight of the trailer and the power of the trailer is trying to push the bike over. So I'm constantly fighting this, making it not practical at all. So ideally, the hitch actually needs to be right down low here. And if you look online, a lot of e-bike trailers have little hitches to the side of the wheel like this. But with any significant weight, that is still going to be pulling the bike over on one side. So you might think, let's just build a frame and have the hitch at the back here. But if I do that, the weight of the trailer is actually going to lift my bike up. And it's actually quite hard to control a bike when it's constantly doing wheelies. So what it needs is equal pressure on both sides of this wheel. And so I built this. This fork is going to bolt onto the original axle. I'm able to steer from side to side, and as I lean on the bike is actually able to twist because of these fancy bearings there. These are similar to the bearings you'd find on a Lazy Susan. You can see the whole thing's laser welded. I put some reinforcement in there as well. So the only thing interesting left to do is to weld this to the original hitch. So let's laser remove some powder coating. And there we are. The cleaning action worked an absolute treat. Now because the laser welds are small, they still penetrate really deep, but I did add these reinforcements on the sides just in case. Because let's face it, there's a lot of weight being thrusted upon that joint. Really, this is a bit overkill for an e-bike. It's probably good for a tractor. So let's fit this thing together. Alright, so I need to remove the old nuts. Right, so I put a lot of thought into this part here. So you'll notice on the forks themselves, I've inserted these phosphor bronze bushings. They're the correct diameter to fit these lug nuts. And these lug nuts happen to fit this bike. First of all, I'm going to put some washers on. Then I need to insert a spacer which fits the lug nut. And now we can attach on our forks. And the lug nut goes straight through like this. Although it is a tight fit, or should I say, a good fit. Do the same on the other side. And then you have to use this special bolt key to tighten it up with. Now, if I do say so myself, that is a tidy joint. That holds the bike really good and strong. And when this isn't attached, all I've got to do is strap it to the top of the bar, like that. Right, let's get this thing hitched on. Just undo this. That's how pin comes out. That should just go straight into there. Easy. Alright, so I'll strap the battery on here. And then the controls plugged in here. Right, all ready to go, just need this foot to come up. Whew. That weight is now all on the bike. Right, parking brakes off, let's give it a ride. Whoa. Well, that feels a lot better. So much so, I think it's dangerous enough to wear a helmet. The only problem I can see is there's still a bit of flex in that joint, so it dips down a little bit. But if we do some heavy haulage now, put more weight in the back, I'm sure it'll be fine. So just using trailer power, let's go. So what it says, 15 mile an hour, but that feels very fast. Now, still not pedalling. What is it like going uphill? Let's have a little turn. Oh, something's cut out. Oh, I don't know what happened there. Oh, let's carry on, see what's going on. Right, so just using its own power going uphill. Let's give it some pedal assist. Right, well, pedal assist feels like nothing. In fact, what it feels like once I've gotten up to speed, it's even easier for it. It's probably the key. Right. So last winter, I actually collected a whole load of logs. Oh, take my helmet off. That's because one of the ash trees fell down due to ash dieback. So before this next winter kicks in, I want to start hauling it back home. Right. So now I think I'll move this further back. We'll try that load. That's a heavy load. I wonder if you can guess how much weight is in this. These are wet, by the way, as well. How is that? That is about right. If I can lift it up a little bit, I'd say that is bang on. Whoops. Right, let's try that. Ooh. Help if I took the brake off. She definitely needs some assistance. Right, let's turn the Cyrusher up to max speed. Right. Okay, well that's doable now. Picking up speed. Let's go uphill past the camera. Turn. Come on, girl. Oh my gosh. I mean, going uphill with a lot of weight, off-road, am I asking too much of her? She's really struggling now. If I can just get momentum. Yes, come on. So the safety mechanisms in this are shutting off when it's overpowering. I can see the voltage up here going up to about 50 volts. Right, if I can just get it to point downhill. It's just that I'm literally stuck in a rut. So that's the issue with it being a low rider. Oh. I do appreciate this going on easily though. I feel like something's stuck in the chain maybe. There we go. I'm going downhill at the moment, now we're going to go uphill. Oh, it's struggling. Oh, that is just no good. That is too much weight. Stitch some of these logs then. Should be better. Right, let's have a go with that now. Well, that was a hill start, so that's a good sign. Yeah, we're picking up speed, which is good. Good success. Kind of. Just normal biking over stubble like this isn't easy in the best of times. So it is a win still. Right, so this has worked, but definitely not to the level that I was expecting it to. And to be honest, I don't think my calculations were wrong, something else is. This is meant to be a 2000 watt motor. What is it actually coming out as? I'm just going to prop the back axle up a bit. Right, those wheels are off the floor now. Right, so on idle, we're drawing 17 watts. Let's rev that engine. I don't know what you saw, but I saw 500 watts. If I put the brake on to assimilate a load, slowly put in the brake on. Okay, without burning up my brakes, I can see 1,575 watts. Okay, so it is close to 2,000 watts. I'm just disappointed that it's not better than that though. But then again, I was putting on quite a heavy load, so maybe it will be better with just the camper. The camper is relatively light in comparison, and then I guess we'll have to take it on a road trip somewhere. Right, let's get the camper finished. Right, so we're back onto spray foam insulation. There's a good chance someone's already commented on the difference between closed cell and open cell insulation. And closed cell is meant to be the bee's knees, that's the stuff you want. And apparently the Demson P90 is almost closed cell insulation, meaning it's not 100%, but it is mainly closed cell. But according to my notes, it has an R value of 5.6. And that's apparently close to mineral wool or PIR insulation. Well, I bought plenty of it this time, so let's turn this over and re-attack it. This is both satisfying and quick to remove. So I'm going to continue just removing all of it because I've got enough spray foam, I think, to completely replace it and do it right. Right, so in between rain showers, I've managed to scrape off most of it. Parts of it are landing on my lawn. And so inevitably, someone in the comment section is shouting as loud as they can on the keyboard, and I've put plastic contaminants and pollutants into my lawn. I've noticed this, and I've done a bit of research to try and figure out how bad that is. And I found out that it's actually quite possible that this does more good than harm. Right, so to explain this point, I'm going to compare this with biochar. So polyurethane is completely inert and does not biodegrade. Neither does biochar. So biochar is extremely porous, creating habitat to microorganisms and bacteria, as well as holding moisture. Polyurethane in this foam form does exactly the same. By adding biochar to soils like clay, it gives aeration and also improves the soil structure. And mechanically, polyurethane foam does the exact same job. And get this, they've actually discovered fungi and bacteria that can actually digest polyurethane foam, whilst I don't think there's the same thing for biochar. Now, don't mince my words, I'm not saying to use this as a soil amendment. What I am saying is trace amounts of this accidentally spilling on my lawn does more good than harm. And if I haven't mentioned it already, I'll repeat it though, this stuff is inert, meaning non-toxic. Right then, let's do this. Well, I guess that's better than it was before. It's extremely inconsistent though. Now I could leave it like this and paint over it and have some sort of psychedelic, psychopathic room, but I think I'm going to stick to my original idea and smoothen all of this out. To do that, I'm going to carve it with one of these. Well, I am seriously regretting my decisions now. Been using a little cocktail stick with a bit of paint on it. That's to give me the desired depth gauge. And in some places I've really not done it right. But more to the point, look at these lovely voids I've got to fill. I've also got a huge amount of waste, which I did not want to happen on this build. Well, I can't stop now though, can I? I've got to carry on polishing a turd. Interestingly, if you've used spray foam on your house in the UK, you are void of getting a mortgage. That's because the spray foam actually traps the moisture in any of the wood that's there, and what they found is that rafters have been rotting out from underneath. But now I'm looking at the inconsistencies and these voids underneath the spray foam. I don't know why anyone would use spray foam. I'm sure a professional with the right kit would do a much better job, but I think my advice to anyone is do not do it yourself. I don't know how I got it so wrong. I'll come up with a solution, don't you worry. Right, so my solution is to stop cutting corners and to do this thing properly. I thought this method would be the most cost effective, but really it's just a bodge. I heard it said recently, if you can't afford to do it right, what makes you think you can afford to do it twice? So I am going to painfully remove everything I've just done, and we're going to do it the best way. This isn't fun anymore. Well, I got it set up for welding, but it's raining. She's in there tight. So that should be the very last weld. So now I'm going to fit the door on. Right, so I'll fiddle with the locking mechanism now. Okay, so you can probably guess what I'm doing. I've doubled the amount of aluminium and put a skin on the inside. And then we're going to use expanding foam insulation again, except this time we're going to pour it in through these little holes. Thankfully, we've got a sunny day and it's keeping this warm. You want it to be above 20 degrees Celsius, apparently. Right, so let me show you what kit I've got for doing it. Right, so again, with my own money, I've bought the 2-part polyurethane expanding foam. This brand is CFS Fiberglass Supplies from the UK. Separately, I bought some measuring cups and some bamboo stirring sticks. Actually got these bits from Amazon just because they were cheaper. And latex protective gloves. The way it works, we mix it 1-to-1, mix it rapidly for 20 seconds and then pour. And I believe it helps also if we aerate part A first. Give it a good whisk. So let's see if this won't go horribly wrong. Right, there's our 2 cups. So this is part A. Okay, so now we'll pour the 2 together. It's getting messy already. Right, stir. Until it goes milky, apparently. Right, let's start taking this over to the thing. Right, so that's the first cup poured. Right, so just off camera, I tried to mix a second batch with the intent that you would actually see me pour it into the cavity. But this time I went a little bit over 20 seconds of stirring and it literally started erupting. I poured as much as I could into the cavity, but it has gone everywhere. And now look at this. This is what was just left after I poured it all. Why is it? It always goes wrong for me. Instructions are there for a reason. 20 seconds, no more, no less. I'm glad I kept this plastic on though for now, so it should come off quite simply. But let's see how much it's actually expanding inside the cavity there. And what I've got with me is an endoscope. So I'll try and record some footage of what's going on inside here. Right, so going in. Here's my polystyrene spacer. Aha, there we go. So there we are. It looks like it's travelling across it quite nicely. How deep is that? Right, so we've got significant depth. Well, I'm happy with that so far, apart from the mistake. Let's see if I can do a better job with the next batch. 13, 14, 15, 16, 17, 18, 19, 20. And you can see that I've made a little funnel just using a bit of tape. That has worked exceptionally better than last time. So this creates a thermal reaction, so hopefully the warmth that is already down there will help this work a lot better this time as well. Let's take a look and see what that's doing. Right, so that's in there. Let's go down another hole. Well, there we go. You can see it climbing. Wow, look at that. That's awesome to see that moving. So I'm just going to wait until all of that is expanded, and then once it's set, it goes rock solid. Whoa. Let's do the next batch. Right, let's have a look at this. And that's coming right to the top now. You can see it. Right, it's going to start. Oh, there you go. It's bubbling out already. Yummy. Don't mind the sheep in the background. There we are. That's coming up nicely. Keep going. That was a good one, that was. Whoa. And there's me thinking there might not be enough. Right, this is the absolute last of what I've got, and I'm hopeful that it will actually fill the rest of the cavity. I mean, if it doesn't, I don't know what I'm going to do. Right, let's see. Yep, coming to the top now. What if I close that off? That's what I should have done earlier with those ones. Filled! Oh my gosh. Hang on. It's going to be a bit to clean up, never mind. So that's it. These are completely empty. Now the rule of thumb, and I could calculate this, but these are meant to expand to 25 times the volume. But that's only if all the conditions are perfect, like the temperature is perfect, the humidity is perfect, the stars are aligned perfectly, politicians going to prison for lying to the public. You know, perfect conditions for things to go smoothly. So what I've seen other people do online is just mix up small batches and wait and see how much it fills and adjust accordingly. I think a bit of excess is okay, but it's a bit to clean up now. So I think it's worth me showing you the waste that I accumulated. I think to give you a realistic expectation. But this stuff is so solid. I literally don't know how I'm going to get it off my bench. Ow. Now, something I will point out, which I think some people will be angry with me about, you should definitely wear a respirator mask. So fortunately, I did this outside. There was a nice breeze, so there was minimal risk there. But to breathe it in is incredibly harmful. So I was risking it a bit there. I advise you not to wear all the safety measures. Right, let's clean it up and go camping. Oh, amazing. So before we marry the camper module to the trailer, we've got some modifications to do. And that is, because we're in an enclosed space, we need some air ventilation. So I've chosen these stainless steel flush seating ones, and they'll simply get attached just by drilling a hole. The other thing I have are these ground anchors. Now, because we can't get access to the ratchet strap hooks, I'm going to use these instead. Now, these also sit nice and flush, but I'm going to have to do some funny cutouts. And to do it, I simply did a paper rubbing. So just hold a sheet of paper, rub it, or you can use a crayon and then cut out the lines. That gives me the cutting template. So I'm not going to bore you with that. I'll just do some more YouTube magic. There we are. Look at that. That'll hold the battery on nicely, and that'll stop me from suffocating. Right, let's marry this thing. There we are. I managed to get the camping module over by recruiting 3 of the most incredible women in my life. That is my wonderful mother, my beautiful wife, and my amazing daughter. And together they managed to Power Ranger and form an average guy to help me, albeit an extremely chatty one. Anyway, they helped me get it here. So to do the manoeuvring, I've also added some handles. But before we marry this to the trailer, I'm going to put some sealing around it. So I'm going to flip it up. So ironically, it's gotten a bit dirty from pressure washing. That's because it's splattered on the mud underneath this pallet and got inside. So I've got some of this special foam strip. This will stop any kind of clattering and chatter between the camping module and the trailer. And this will help just a little bit to stop that heat transfer from escaping. But not a lot. Right, so there's only one thing for it. Let's put the two together. So it's looking good widthways, but I'm struggling to get it to come all the way back because this post is actually leaning slightly back. So what I'm going to do is just loosen these bolts a bit. I'm so glad I made this a bolt-on design. I've had to make so many adjustments. No. I mean, that's not great, but it is just the one that's done that, so maybe I can re-tap it and get away with it. It's fitted, actually fitted. Right, so I've ratchet strapped this down so the foam cushioning now is all compressed. And it turns out I've put my riv nuts in the wrong place still. So now I'm just going to drill and tap some holes around it and bolt it on. There we are, that'll do nicely. Right, that's all bolted on now. The main concern is that the riv nuts have a much more longer thread depth than just the wall thickness of the steel. So these bolts aren't as strong as they could be. So I'll have to watch those. But let's see if I can get this tow hitch back on, shall we? Whew. I've got another problem. Come on in, let me show you. I appear to have damaged this cable. You can see just there's a nick which must have happened when moving the module on the trailer. Now in retrospect, the cable is actually too short anyway, so I do need to replace it. Either way, I've got a new cable. It's not ideal, but I'm going to splice it together with this connection. Yes, I wish this was a 48 volt DC supply only, and that we didn't use the dangerous 220 volts in the system. Anyway, I'll probably intend to change this at a later date. I just want to fulfill the proof of concept first. And while I'm here, I'm going to do some cleanup in areas. So this is a polyurethane foam remover. So it's leaked on the panels a bit. That should help get rid of it. And then I guess we'll start taking off some of this wrap. There's so many scratches, I can't satisfyingly just pull it all in one, unfortunately. Aha. Apart from the odd bump and scratch, that's actually looking amazing. So the areas where the aluminium's been exposed to the elements, there's a bit of oxidization. I have given it a bit of a clean, but I'll also give it a bit of a metal polish. Right, so I feel like I've buffed out the worst. Now I need to protect it. I've decided to try a ceramic spray coating from Turtle Wax, because what I don't want to happen is the aluminium to start oxidizing, so hopefully this should stop that. If there's any products you recommend, by the way, I'm not saying anything that I've used is the best or any good, I'm just testing it all. Do you know what? I think we're done now. And I'm so glad about it too. This has gone on way too long. Well, there's only one thing for it then. Let's get it loaded up and take it on a small adventure. Right, so for a period of time, we're going to have to be on the road. Now, the law regarding bike trailers, you must have red reflectors at the back. I've actually put some all the way around, just to be sure. So the maximum footprint also can't be any wider than 1 metre and no longer by 2.5 metres, which is pretty much exactly what I've built this within. Now, if you look really closely, you might notice I put little brackets on the side here. They are to accept these. These are wireless indicator tail lights. Super useful for building your own trailers. I just had to knock up my own brackets for them. That one goes there. So it's got a range of different settings, but to be able to indicate, that is brilliant. And this obviously clips onto my handlebars. Right, let's get it hitched up. So to make this actually legal now, we need to turn on our motor restrictor. I've also disconnected the battery, and I'll also take the key out. And the twist throttle here, I'm going to have to unplug. There we go. That is now not possible to be engaged if ever the police officer asked. So the legality is actually a bit of a grey area. So I don't recommend anyone else attempts this without consulting a police officer first. I'll certainly keep you updated if ever I get in trouble. I've got a beautiful location in mind. It's a bit of a trek to get there though. So let's see how it goes. Right. So I thought before I put people's lives at risk and take this on the road, because let's face it, it's not the wisest of decisions when I haven't fully tested it yet. I thought I'd go around the field first. And this is where I'm in conflict with the law a little bit. Because without the power, it's near on impossible to pull this trailer. Going up any kind of incline, the bike alone just can't manage it. But with the built-in motor that the trailer has, we don't seem to be going above the 15-mile-an-hour speed limit, and it enables me to take this heavy load up a hill using a bike. Anyway, I know a little location that doesn't require us to go on the road. Let me just show you how it all handles. So here's a good test. We're actually going downhill now. So is the trailer going to start pulling me over, especially when we go around corners? No, that's okay. How does the bike brakes handle with this load? just fine, I think. I think I've forgotten something. Yep, we're going to have to go back up the hill. That's okay, that's a good test. Well, off-roading uphill. Whoop. She's doing good. That's what I wanted. My little action camera stick. Don't forget my hat as well. Come on, keep turning. There we go. While I'm here, I'm going to grab some twigs for my cup of tea. There we go, that's all I need really. Oh. Well, that's annoying. That must mean my stuff's fallen out the back. That's not great. Drama! There's my bike falling over as well. Alright, see if we can find those bits. I see something over there. That's my sleeping bag. Oh, it's opened again. Oh. Stand. Oh, there's my other piece. Oh, there's my camera. Honestly, of all the things that I thought would go wrong, I didn't think it would be that silly door. That's my Kelly kettle. That's what I was going to cook my cup of tea on. Oh, it's good I did this test, isn't it? Don't want to be losing this on a road. I mean, to be fair, these are good solid cameras. Really need my microphone though. It's going to take me a while to hunt that down. The shaking, obviously, for whatever reason. I think the only thing I'm missing now is my microphone. So I'm going to unhitch and look for that now. Well, good news, I found it. You're probably wondering, how on earth did I find it in this whole field that I just rode around? Well, that's because the little receiver itself tells me if there's a signal. So the higher the bars, the closer I am to it, to the point where I could actually find the thing. Amazing. Well, I don't know about you, I need a cup of tea. So let's find a place to rest up. I think that's enough adventuring for today. So while I'm lay here, nice and comfortable, I thought I'd go over the expenses. And I can honestly say, this is quite depressing. So steel first, the 50 by 25, that's £16.50 a length. I needed 2 lengths of those, that's £33, that's not bad. I did have to get some 150 by 6mm flat bar, that was £58.50. But then moving on to the aluminium, that's of £66 a sheet. I needed 6 of those altogether, so that's £339. I'm rounding everything to the nearest 50p, by the way. The actual tread plate that I'm lying on, that's £75 a sheet. Now, I did use some bits out of my scrap pile, so I don't want to include that, because technically you'd have to buy a whole 6 metre length otherwise. So the pourable expanding foam, that was £88. Plus the gloves and cups and sticks and that came to an extra £30. Now get this, I spent £117 plus £28 plus £26 plus £13 on the spray foam insulation. That's plus £8.50 for the spray gun and another £5.50 for the cleaning aerosol. So I wasted a total of £198. Gosh, that's painful. So in your build, don't waste that. So that's double the amount than if I just did it properly in the first place. So the wheels were £43. The axle, which I got on a special deal, is £85. Right, but then there was a load of bits, just like lots of stuff. Got toggle clamps, £8. Lug nuts, £28, because I had to buy a whole kit. Hold down plates, £16. Bushings, £6. Hitch pin, £10. Bearings, bolts, washers, £33.50. Extra bolts, £12. Pack of air vents, £13. Still got loads left of those. The whole saw for doing it, £8.50. Turtle wax, £12. The lifting handles, got a pack of 4 of those, that was £19. That lock was £14.50. The hinges for the door were £14. The window, which I'm really pleased with actually, was only £29. The tail lights were £22. All the reflectors and a pack of those glands was £27.50. And the pin for the drop down leg was £5.50. I then got 4 in the pack. So just those little bits alone was £278.50. Oh, that's a lot of money. But that doesn't include the things that I didn't spend money on. So the Anker Solix F2000 is currently on a special deal at £999. Let's just call that £1,000, just for sake of argument. Now the Viva motor apparently is £220. That was given to me to test out, but British Viva doesn't sell electronic products anymore, so you have to find it on eBay. Now the Vertiv 48 volt power supply was £140. I did buy that, but that was for a different project, so I didn't feel like I could include it. So just those bits to make this trailer work is an extra £1,360. That brings the total cost to £2,382. And you could probably argue there's a lot more extra because I haven't included all the little bolts and stuff either. So that's just cost. I mean, to actually make it and put a wage on that for someone to build this, it doesn't bear thinking about, I think. I mean, you'll have to ask Convert Designs, but I bet you the designing alone would cost a fair bit. And I think it's quite safe to say that the equipment that I used to build this probably cost in the region of about 10 grand or so. So I think it's safe to say there's a reason why people don't build these. Apart from the bits that went wrong, it was a lot of fun and I learned a lot.
What I also didn't include was, of course, the powder coating. That was an extra £120. Also, I found out what was wrong with the door. It drops slightly, just needs lifting up before you can lock it. So it requires me just to do a little bit more filing, I think. And if it was a sunny day still, I would have brought the solar panels out. Well, they'd charge the battery system and charge the bike at the same time. But here's the question. Was this whole build a complete waste of time and money? Well, before you answer that question, I would love to know what parts of this video you found most valuable. Now, as far as I'm concerned, I learned a huge amount. I'm very much looking forward to learning more from what you guys say in the comment section. The thing for me is I didn't expect this project to take as long as it did. I basically just took on the opportunity with the e-bike and the battery systems, but mainly because my son wanted me to build a camper. So I'm going to spend some very valuable time with him going fishing with it, I think. I mean, what if I could make these even cheaper and make them as emergency housing for the homeless? Or maybe I could even use the same techniques to build a boat. In the meantime, what I encourage on this channel is to watch less and to do more. And with that, I hope that you can forge for yourself a life worth living. And I'll see you in the next episode. Bye-bye.